Hello children, welcome to Vidyalakshmi YouTube channel. This is your Shaktivel Max teacher. Today we are going to see class 12 mathematics chapter number 1 relation and function. We are going to see. Okay? Right. See, first definition, relation R in a set A. Relation R in a set A is called empty relation. First itself they are talking about a empty relation. Empty relation in the sense no element of A is no element of A is related to any element of A. Okay, no element of A is related to any element of A. For example, in A, there is any element. For example, 1, 2, 3, 4, like this. Okay, this is a A set. In the A set, no element is matching to A. It's called, what is that? Empty relation. It means R is equal to empty you will be getting. R equal to what you will be getting? Empty. The empty can be, what is that? Subset of a cross product you will be getting. Cross product. In 11th we have studied what is the cross product. That means Cartesian product they will be saying. Okay, A cross A. Right. Next definition to relation R in a set A is called a universal relation. Means, see, when we have a cross product, if you have a empty, it will be subset of cross product. This is called empty relation we have seen. Okay, like that. Here, universal relation in the sense, actually, this R means relation. R means what? Relation. R means relation. The relation will be empty, then it's called the empty relation. One more thing, the R is equal to the whole Cartesian product if you get, means A cross A. The relation R is equal to whole Cartesian product if you get, that is we can say universal relation. Universal relation in the sense, whole cross product will be equal to the, what is that relation? Understand? Right. That is, they are telling that each element of A is related to every element of A. Okay, each element of A is related to every element of A. That is, R is equal to A cross A. Understand? One more thing we know, both empty and universal relation, sometimes called a trivial relation. One more thing. Okay, listen carefully. Two things we have seen. Two things. One, empty. Another one, universal. Empty example I will give. Example. Suppose A is equal to, I am taking one simple will take. We'll take A is a girls' school I will take. A is a girls' school. Right. A is a girls' school. Right. Now, what is the relation in the sense? Relation actually, X such that X belongs to the A, where X is what in the sense? X is what in the sense? X is brother of everyone. X is brother of someone. Okay, X is brother of what is that? Someone or anyone. Brother of anyone. Children, listen. It is the empty relation. Why? Listen carefully. R is equal to what I said, X, where X is what I said, brother of anyone. Since A is a girls' school, no one can be brother of anyone. Have you noticed? Since A is a girls' school, no one can be brother of anyone. So that R what we can say? Empty relation. R what we can say? Empty relation. This is R1. R1 I will take. Example for a empty relation you can take. Example for a empty relation. Suppose example for a universal relation. Example for a universal relation. Universal relation in the sense what I said, R is equal to full Cartesian product will be equal. Right. Then for that what is the example? What is the example we'll take? R2 is equal to X such that X belongs to A and X is sister of anyone. Sister of anyone. See children, see since A is a girls' school, since A is a girls' school, surely all the girls we can say is a sister of someone. Am I right? Surely. Yes, you can say this. Okay. Since A is a girls' school, every girls we can say each other they will be sister like that. Not an issue. Then whatever the relation you make there, it will be equal to the what? The full Cartesian product will be equal to the relation R. It means, what is the Cartesian product we will be doing? Suppose x1 is a one girl, x2 is a one girl, x3 is a one girl. Na? When you do a relation with this, here we have a x1, x2, x3. Just I am showing in the arrow diagram, x1, x2, x3. Okay. Now x1 is a sister of herself. And x1 is the sister of x2, x1 is the sister of x3, like that. x2 is the sister of x1, x2 is the sister of x2, x2 is the sister of s3, like that. One more. x3 is the sister of what is that? x1, x3 is the sister of x2, x3 is the sister of x3. We can make like that. All the relation is a true based on R2 condition. Everybody's sister. So that we can say this. What? R2 is equal to A cross A. Have you understand? Right. Now this is the definition we have seen, that what is the universal relation, what is the empty relation. One more what I said, one more. The empty relation and universal relation, sometime it's called a trivial relation. Also we have to note. Right. Based on that, one more example will go. I see we are taking one example question. Right. So A be the set of all students of a boys school. What they are telling, A is equal to set of all boys student. Boys, set of all students of a boys school. Then what it mean? Everybody are boys in this school. Everybody boys in this school. Show that relation R in a given by. So R is given what? R is equal to given a relation A comma B such that A is a sister of B. A is sister of B. If you take like that, it will be empty relation. That is we want to show. That is we want to show here. This is show that. Okay, that is we want to show. It will be what? Empty relation they are asking to show. See, I already told you, since A is a boys school, surely no one will be sister of anyone. Am I right? So, write your answer here. Since A is boys school, no one can be sister of anyone. Okay. So that R is equal to what here? Empty. No one can be sister of anyone. In the sense, R is equal to what? Empty. Since this is a boys school, no one can be sister. No one can be sister of anyone. Understand? So that it will be empty relation. What we can say that? Empty relation. That's it. Okay. R is a empty relation. Next. Next what actually? R dash they are talking. R dash what they are telling, will take R dash. R dash is equal to A comma B, where difference between height of A and B is less than 3. So A and B is a two students. Two students height when you subtract. A, B height when you subtract, it should be less than 3. Less than 3 they are telling. See, this is actually universal relation only. Why? Whoever you take in the school, suppose the tallest person will be 200 centimeter, for example. For example, I'm taking one fellow is at 200 centimeter tall. One more student I'm taking 150 centimeter. When you convert into meter, 2 meter, 1.5 meter. When you subtract these two, what you will be getting? 2 minus 1.5 is a 0.5 meter. If we take little more tall also, one fellow we have 2.5 meter, 2.5 meter. One more fellow 2 meter tall. When you subtract this 0.5, what I'm telling you will not get 0.5 always. It means it can come any answer, but that answer can be less than 3 meter. The answer can be less than 3 meter. Any student you take from the school, their height difference will be less than 3 meter. In the universal, you go anywhere else, you take two child, their height difference you find, you will be less than 3 meter. So that this will be universal relation. So obviously you can write directly. So R dash is, what is that? Universal relation. Universal relation. Directly you can write, because that you can write difference between any student's height is less than 3 meter. Enough. Understand? This is example 1. Very easily you can go. Understand, children? We are going example number 2. Before going example number 2, based on that example number 2, we have a definitions. The definitions you want to see. Okay. What is the definition number 3 says? Definition number 1, what we have seen? Empty relation. Definition number 2, what we have seen? Universal relation. Both empty and universal relation is called trivial relation. Don't forget, just you recall. Empty means what we have to say? No element is matching with any element of E or every element of E. Like that. Universal, what is the relation in the sense? Every element of A is related to any element of A. Or else Cartesian product will be equal to the relation. Like that you can say. Here, definition number 3 is what? A relation R in a set A is called reflexive, symmetric, transitive. See, before going this, you want to read about R is equivalence relation. R is equivalence relation. What is equivalence relation? Yeah, the relation R is satisfied reflexive, symmetric and transitive. In the sense, we can say that R is called equivalence relation. Then for studying equivalence relation, we have to study about reflexive, symmetric and transitive. Have you understand? Right. Now that you leave it. First, reflexive in the sense what? Reflexive. Reflexive in the sense, listen carefully, we have to take one element. If you make a Cartesian product, that pair should be belongs to in the relation R. For example, A comma A should be belongs to in R. Here, for all A belongs to the A. Small a is denoted element. Capital A denoted set. Understand? Right. So, if you are taking an element in a A, that element should be paired to itself. Means it should be related to itself. If I am telling 1 in the sense, 1 should be related to 1. That we can write 1 comma 1 belongs to R. Understand? 1 comma 1 belongs to R. So, belongs to in the sense, this 1 comma 1 pair, set ordered pair, should be in the relation R. That is the meaning. Understand? This should be satisfied is called reflexive. Okay, wait, for all together I'll give one example. Next is symmetric. Symmetric in the sense, 2 element we need. 2 element. Suppose if I'm taking A1, A2 is belongs to the R. A1 comma A2 belongs to the R. R means relation. A1, A2 belongs to the R in the sense, their reverse also will be in R. Reverse is what? A2 comma A1 should belongs to R. If it is satisfied this result, then only we can say it's a symmetric. Then only we can say which is what, my dear? Symmetric. Otherwise it is not a symmetric. Understand? Right. Next, what is the transitive? Transitive in the sense, same manner. Transitive, we have to go 3 pairs. 2 must be belongs to here in the what is that symmetric for all A1 and A2 must belongs to the set A. Okay, from the A set only you should take 2 element. By using 2 element, if you make a ordered pair, that should be means their the reflexive should be there here. Understand the mirror point view. You will, what is that you can say x comma y in the sense y comma x, or 1 comma 2 in the sense 2 comma 1. The opposite view, mirror point view. That if it is belongs to R, this also should be belongs to R. 1 comma 2 belongs to R, 2 comma 1 also belongs to R. Then only R will be symmetric. That is we have seen. Right. Next we'll go to the transitive. Okay. Transitive will take A1 comma A2 and see where I am ending. The first pair where I am ending in A2. A2 you have to start with the second pair. A2 comma the continue will be A3. This both should be belongs to R. This both should be belongs to R. Then what do you want to get? The common should be is there, I'm right? The common without this, without the common A2, remaining I need what actually as a output. The output what I'm getting, that should be in the relation R. Listen carefully. First two should be in the question. Any two you take, in that first two should be in the relation. In that common thing, if you leave now, first one of the first pair, second of the second pair should be make one pair, that is also should be there in the relation. Okay, for all this I will give an example, then you will understand clearly. Here also A1, A2 and A3 should belongs to R. Here also all the three terms are all the three elements should be belongs to R. Understand? Right. Example will go here. Example for this what? I will take any situation, any simple situation I will take. Suppose A is equal to 1, 2, 3, 4. This I am taking my own example. In this relation R says what actually? Generally you write anything. Suppose 1 comma 1, 2 comma 2 and 3 comma 3 and 4 comma 4. Just I'm making the pair, anything. Okay. And 1 comma 4. Next what is that? 1 comma 3. Next 4 comma 2. Okay, like that you just make a pair. And 2 comma what we can take? 2 comma 3 and 1 comma 3, just anything, whatever, just I thought I wrote here. Okay, now we should check first reflexive. Reflexive in the sense what? Listen, through example you will understand little more. Reflexive in the sense what? See, for every element, for every element of A, it should form A comma A in R. I mean, it means how many elements we have in set A, for all the element should be formed A comma A in the R. Then only it will be reflexive. Okay. Means, listen, I have a 1. 1 in the sense what? 1 comma 1 should be formed. It's here. Have you noticed? Next, 2 in the sense 2 comma 2 should be formed. Next term 3 in the sense 3 comma 3 should be formed. 4 if you have, 4 comma 4 should be formed. Then this R is a reflexive. This R is a, what you can say, reflexive. Reflexive satisfied. So the thing you want to realize what? How many elements we have in set A. For all the set A, it should be there like this in the relation. It means A comma A. 1 means 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. If you have an R, then only the R is called reflexive. Understand? Next, symmetric will go. Symmetric, whether it is satisfying or not. Listen, symmetric, how you have to check? Listen carefully. Symmetric, you don't want to go in question. See, reflexive, I went through question, I answered. In A, how many elements we have? For that, ordered pair should be satisfied, I said, for a reflexive. But symmetric, not like that. See the relation. Means here, this is a relation also question only. This is A. By A, we are checking the reflexive. Symmetric, by R, we are going to check. Understand? How? Listen. For how many pairs we have? For all the pairs, we have the mirror point of view. It means A1, A2, if it is there in R, the reverse portion also should be there in R. That should be satisfied for all the thing. Otherwise, it is not possible. Listen. If I am taking 1, 1, mirror view what? I mean opposite view. Same 1, 1. No change. The element you should change the x term in y term in x ma. That's it. 2 also what? 2, 2 if you take. Same 2, 2. Satisfying. Understand? 3, 3 if you take. What will happen? For this also mirror point view. 3, 3. Satisfied. 4, 4 if you take. For this mirror point view what? Again 4, 4. It is there in the... See, this is there in R. Our output is what? Whatever we have here, this is also in the R. So this is satisfying in RR. So that is what I gave tick. Second, 1, 4. 1, 4 if you take, whether it is there in a... Sorry, 1, 4 means what is the mirror point of view? 4, 1. 4, 1 whether we have in a question, means in the relation? No. Like this, any one is not there also, we have to say not a symmetry. For all the pair, you have to check whether mirror point of view, whether it is there or not. If it is not there, we have to say it's not a symmetry. Simple. Have you understand? You check everything. Suppose 1 is not there also, not symmetry, just you check. 1, 3. 1, 3 means 3, 1, 3 I wrote twice. So 3, 1 you take, for example. So 1, 3 if you take, there is 3, 1. Not an issue. Okay? Not an issue. 4, 2 if you take, 4, 2 if you take, 2, 4 should be there. It's not there. That is also a problem. And 2, 3 if you take, 2, 3 if you take, 3, should be there in R. Is it there? No. See, any 1 is not there also, not a symmetric. Here 3 is missing. So that surely it's not a symmetric. Have you understand the symmetric is what? That's it. Symmetric, that's it. Okay. Next, what is that? Transitive. Next to where I'm going, transitive. Transitive also, you see, any two you take, that third thing will be there in the thing. First I'm taking 1, 1. End point what we have, in that it should be start. So here 1, 4. You can take 1, 1, 4. So if you are taking 1, 1, and 1, 4 is both belongs to R. Your output must be what? 1, 1 if you leave, 1, 4 should be there. Also belongs to 1, 4 here we have. Then tick. First one, okay. Second, 2, 2 if you take, starting with 2 I need something. 2, 2 you take. 2, 2 and starting with 2 I need anyone. Start here, 2, 3. 2, 3 you take. It's already belongs to R. If you leave the second and first, what you should have? 2, 3 belongs to R. This is there here. Then okay. Like that everything you should check. Next 3, 3. 3, 3 if you take, starting with 3 you need one term. Because end term is what? Starting with that you need. Is that, here what we have? 3, 1. So 3, 3 if you cancel, what it should have? 3, 1. 3, this should be belongs to R. This also should be belongs to R. Then we have here, this also okay. Like that you should check. 4, 4, what is that you have to take? 4, 4. 4, end number is 4. Then starting with 4 you need something. What is that? 4, 2 you take. 4, 2. 4, 4 if you cancel, output is what? 4, 2 also belongs to R. Then you can say, okay. Next term. Where I'm going? Next this over. 1, 4. Okay, I show. Okay, this also you take. 1, 4 means 1, 4 if I take, starting with 4, 2 you can say. 4 cancel. 1 comma 2 must be there. Is it there here? 1 comma 2? That's it. 1 is missed. Have you noticed? 1 comma 4 I took. Starting with 4, 4 comma 2 I took. So 4 if it is missed now, 1 comma 2 must be in a R. 1 comma 2 is missing. So not a transitive. Have you understand? Like that only you have to check. I hope through this example you understand what is reflexive, what is a symmetric, what is a transitive. Understand? So this example is very important. So any example satisfying all the three, that R means that relation is called the equivalence relation. That relation is called what I said, equivalence relation. Have you understand, children? That is the important point you want to note down. Okay, right. So we are entering in the next. What is that next? Which I said the equivalence only. Okay. Suppose R is the relation in a set A. It is to be equivalence relation in the sense, then R must be satisfied this all the followings. Means it should be satisfied reflexive, it should be satisfied symmetric, it should be satisfied transitive. We have seen what is reflexive, what is symmetric, what is transitive, the previous slide. Okay, right. Okay, that's it. The continuation we'll see in the next video, children. Means based on the reflexive, symmetric, transitive. Means what is equivalence relation based on the examples and questions we'll see in the next part. Thank you, children. Subscribe the channel, like this video and share to your friends also. Thank you. Bye.